Today, we're going to dive into a pretty simple idea that's having a huge impact on making our digital lives safer, one software bug at a time. It's a fantastic story about how just changing your perspective can solve a massive problem in cybersecurity. And when I say massive, I really mean it. You see this number, 16,000? That's about how many bugs have been found in the Google Chrome browser alone, using one of the most powerful tools we have. And, that's a huge win. But here's the thing. What if that amazing tool, for all its successes, is actually kind of inefficient? What if it's spending most of its time just running in circles? Well, that's the big question we're going to unpack. Okay, so to really get why this new approach is such a breakthrough, we have to understand the battlefield. And in software, it's this constant, never-ending hunt for hidden bugs and vulnerabilities that could, affect all of us. The hero of the story, our main tool, is a technique called fuzzing. Now, the best way to think about it is like a tireless robot that just throws millions of random, weird, unexpected things at a program, just trying to make it crash. It's a bit of a brute force method for sure, but it is incredibly good at finding security holes on a massive scale. But here's the catch. While fuzzers are awesome at generating a ton of inputs, they're not always that smart about it. They can get stuck in a rut, They end up testing the same well-worn paths inside a program over and over again, and they totally miss the dark corners where the really nasty bugs are hiding. So let's get right to the heart of it. Why does our best bug hunting tool keep getting stuck in this loop? What's really going on here? This is where the researchers had a really fascinating insight. This quote here really nails it. If the fuzzer keeps doing the same kinds of tests, the information content from each one is super low. The fuzzer isn't learning anything new. It's just busy work. And realizing that, that changes everything. And that right there, that brings us to the breakthrough. A total shift in perspective. It's not about searching harder. It's about searching smarter. So this is the key. The whole idea is, what if we stop thinking about fuzzing as just hunting for crashes and start thinking about it as a process of learning? The goal shouldn't just be to run more tests. The goal should be to get the most new information possible from every single test you run.
Now, to pull this off, the researchers went back to a classic idea from the 1940s, Shannon's entropy. Put simply, entropy is just a way to mathematically measure surprise or new information. So high entropy means a big surprise and lots of new info. Low entropy means, you totally saw that coming.
And this urn analogy just makes it so clear. On the left, you've got an urn that's almost all white balls. Pulling one out, not surprising at all. That's low entropy, low information. But on the right, with a great mix of colors, every single draw is a surprise. You learn something new. A smart fuzzer needs to be drawing from the high entropy urn every time. So they took this powerful idea and built a brand new tool designed specifically to be an information maximizer. They called it Entropic. How Entropic works is actually pretty simple and elegant. First, it measures the potential for surprise, the entropy, for every starting point it has. Then, it prioritizes. It builds a power schedule that gives way more time and energy to the starting points that promise the most new information. And the result? It discovers new parts of the program way, way faster. Okay, so this all sounds great in theory, right? But does it actually work in the real world? Let's look at the results, because they are pretty staggering. The team put Entropic to the test on something called the Fuzzer test suite. You can think of it like the Olympics for bug hunting tools. It's got complex real-world software like OpenSSL. This is where the rubber really meets the road. And the results were just crystal clear. What you're looking at here is a comparison of how much of a program's code each fuzzer could explore, that's called code coverage, in just 1 hour. And as you can see, Entropic consistently got the same amount of coverage as the original fuzzer in less than half the time. That's right, it's more than twice as fast. Just by focusing on learning instead of brute force, Entropic makes the whole discovery process way more efficient. This isn't just a little improvement, it's a genuine leap forward. But they didn't stop there. They scaled this whole thing up, running Entropic against the original fuzzer on 263 different open source projects. I mean, we are talking about 58 million lines of code here. And the results absolutely held up. In over 3/4 of these head-to-head showdowns, Entropic was the clear winner, exploring more of the software than the old tool. This was no fluke. It's just a fundamentally better way of doing things. And honestly, this is the most important part. I mean, more coverage is great, But the whole point is finding bugs, right? Well, Entropic found real-world crashes faster. And what's crucial is that it even found some bugs that the original fuzzer had completely missed, no matter how hard it worked. So what's the ultimate proof of its impact? This number right here, over 25,000. That's how many machines at Google are running Entropic right now, continuously protecting some of the most critical software on the planet. This isn't just some research project, it's out there, defending our infrastructure as we speak. This quote from the authors really brings it all home. They point out that this incredible breakthrough didn't happen behind closed doors. It happened because the science was open, the code was open source, and the community could build on it together. And that leaves us with a final thought. Yeah, this was a story about finding software bugs, but the real lesson here is about the power of changing your perspective. It really makes you wonder, right? What other huge problems are we facing, where the solution isn't just to work harder, but to find a completely new way of learning?